Okay, Chapter 7, Section 6 is on solving rational equations. So far with Chapter 7, we've been simplifying a lot of rational expressions. This is the first time we've had an equal sign. Meaning an equation we have to solve, we have to try and find the value of x. Whenever you have an equation, you're typically going to be solving or evaluating it. In this case, we want to find the value of x. I still need common denominators. The LCD is going to be the main task for all this. Find the lowest common denominator. With this problem here, every term has either an x or an x plus 2 in it. So the LCD of this equation is x times x plus 2. And I don't want to distribute that. I want to leave that the way that it is. So I look at each individual piece and I ask the question, what does each individual little piece need? This needs an x plus 2 on top and bottom. I'm multiplying by 1. This just needs an x on top and bottom. And this also needs an x plus 2 on top and bottom. Now everything on the bottom has an x times x plus 2. It's very important that you get everything to have a common denominator. Now I'll simplify the top. I get x plus 2 plus 2x plus 3x plus 6. Now here's the really nice thing about getting a common denominator. Once everything has a common denominator, you can just drop the denominators. It's really like I'm multiplying everything by the LCD and it's all canceling. I just don't bother showing that step. You can just drop the denominators. This gives me 3x plus 2 equals 3x plus 6. And in this problem, something pretty interesting happens. The x's cancel. We get 2 equals 6, which means this problem had no solutions. It couldn't be solved to begin with. That might seem like a waste of our time. Why solve a problem that can't be solved? Because you have to know it can't be solved before you solve it. That problem had no solutions. So my goal is always to get a common denominator and then drop the denominators. You have to think of 2 as a fraction. That is the number 2 over 1. So my LCD here is going to be 12. So I'm going to have 4x over 12 equals 3x over 12 plus 24 over 12. I multiplied this by 4, this by 3, and this by 12. Now I can drop my fractions. 4x equals 3x plus 24. Subtract a 3x from both sides. X equals 24. Good. Keep going. Don't forget about proportions. This common denominator stuff is still very nice, and it can always work. But if you ever just have 2 fractions that are equal to each other, you can still solve it by cross-multiplying. A proportion is 2 fractions that are equal to each other. So this would become 4 times x plus 3 equals 5 times x minus 4. And you get 4x plus 12 equals 5x minus 20. Subtract a 4x from both sides. Add a 20 to both sides. 32 equals x. And it doesn't matter if the fractions or if the variables are on top or the bottom, it makes no difference. Had I instead gone about this by finding a common denominator, which sometimes you'll just get in the habit of always finding a common denominator, that's okay. Well, that'd be 20. I'd multiply the top by 4 over here and the top and bottom by 5 over here to give me 4 times x plus 3 over 20 equals 5 times x minus 4 over 20. And then I could drop the 20s. And what do you know? This looks just like this.
Is my guy from going to screen with you?
Okay, this next one is going to have what we call an extraneous solution. An extraneous solution is a solution that when you solve comes out and looks good but doesn't actually work. It often happens if you have a quadratic or a square root when doing problems like this. And I think I pulled this problem straight from your book's examples actually. I'm going to make this a fraction. Everything needs a common denominator, an LCD, which is x plus 1. So I'm going to multiply the top and the bottom of this by x plus 1. So I get 8x over x plus 1 plus 4x plus 4 over x plus 1 minus 8 over x plus 1. And I said plus, I meant equals. This should be an equals sign right here. Okay, when I solve this, I can drop all the denominators because they're all the same. So I get 8x equals 4x plus 4 minus 8. I simplify, so 8x equals 4x minus 4. I divide both sides, or I'm sorry, subtract a 4x from both sides. And that gets me 4x equals negative 4. I divide both sides by 4. And I get x equals negative 1. Now this looks like a fine solution. But if I take it and plug it in for x, it turns out x equals negative 1 is one of the things that this can't be. Because if x is negative 1, when I plug in a negative 1 for x, this becomes 0 on the bottom. And we can't have a 0 on the bottom of a fraction, and that gets us undefined. So this problem actually also has no solutions. It had an extraneous solution, but the x minus 1, x equals negative 1, being extraneous doesn't actually count. So whenever you get a solution in these problems, you have to actually check it. Check to make sure it works. In this problem, we didn't have to worry about extraneous because we couldn't ever divide by 0. In this problem, we did. Had x been 0 or had x been negative 2, it wouldn't have worked. Our solution actually was already undefined, or no solutions anyways. This one doesn't have to worry about extraneous because there's no x's on the bottom of the fraction. Extraneous only happens if x is on the bottom of the fraction. This will be our last example. I just want to show one that has some factoring in it. I'm going to do 3 over x plus 2 minus 4 over x minus 2 equals 1 over x plus 2, x minus 2. I factored the bottom. And that is our LCD, fortunately. The LCD is x plus 2, x minus 2. So I look at each fraction and see what it needs. This fraction needs an x minus 2 on top and bottom. This fraction needs an x plus 2 on top and bottom. This fraction doesn't need anything. So now I get 3x minus 6 minus 4x plus 8 equals 1. I did those in parentheses because I want to be very, very careful to distribute this negative to everything. So I put it in parentheses to make sure I distribute it. And then I just drop the denominators because they're all the same now. 3x minus 4x is negative x. Negative 6 minus 8 is negative 14, so negative x minus 14 equals 1. This means that negative x equals 15. Sorry, I'm writing quite poorly. So x equals negative 15. Our answers on this video have been kind of clean, and they will very often not be clean with these types of problems because you just get a lot of fractions, but that's okay. Thank you for watching. Have a great day.